Thank you guys for coming. We are the Mutual of Omaha observability platform project, and yeah, we'll just get started. So about the company, Mutual of Omaha is a Fortune 500 insurance company, insurance solutions company. They're based in Omaha, Nebraska, and they offer a variety of financial solutions products for individuals and businesses across the United States. To support these projects, they have a large distributed architecture, which our project is mostly concerned with. So our problem is that Mutual of Omaha was not able to quickly display the processes of their online distributed architecture. Monitoring these processes is important because they could stall, bottleneck, or take longer than expected within the distributed architecture. So if left unchecked, this problem could limit Mutual of Omaha's efficiency. Business executives and developers could monitor these problems and hopefully optimize the platform. So here are our stakeholders. Our sponsor, Adam McQuistan, Cindy Stevens, Jared Durr, and Alicia Huntington. And then we have our faculty and staff. We have Melanie Kugler-Wright as our project manager, Bonita Sharif as our tribe lead, and then Merritt Crackle as our industry coach. And then I'll introduce myself, Ryan Thomas. I was the squad lead and product manager for the team. And then David Dubchikov as a developer, Mitchell Texel as a developer, and then Alex as our development manager, and then Juan Martinez as a developer.
So, all right, so moving on to our problem and opportunity. We were challenged. The challenge was that within the Mutual of Omaha's extensive distributed architecture, the complexity of processes often leads to bottlenecks and performance issues. Identifying and resolving these issues efficiently is crucial for optimizing operations and enhancing the overall system's performance. In terms of our solution, our project aimed to tackle this challenge head-on by developing an observability data tool. This tool allows Mutual of Omaha to systematically track and analyze observability data, enabling detection of bottlenecks and performance hurdles across their distributed architecture. Our solution primarily focuses on detecting what system initiates a business process to understand who uses the system the most, and keeping track of the length of time of a business process to optimize workflows. So moving on to our solution, I'm going to skip to the next slides. I think it's easier to explain it this way. So this is a model of how the data moves through the distributed architecture. As you can see, there are actions that send a command to an application to initiate some business process, and then that returns a response and sends out an event to alert the system of the change. So this continues to carry out business processes, and these business processes are then collected in our Kafka queue in order of their occurrence. And this diagram right here is just representing our application and what it is doing to the data. So you can see the data immediately gets inserted into the raw data table and the unused correlation data table. The raw data table is just a raw dump of everything from the Kafka queue, and then the unused correlation was kind of the hardest part of this design. There was no way to identify when a process was actually ending, so we had to come with a creative solution to ensure that we only select processes when they have completed. So we used an interval, and we said it's like an hour, and then we used a delay filter to only select processes that were that occurred more than 10 minutes ago, or whatever we set that delay to. Then these processes are then distributed across our 4 different tables here that are actually used to answer our questions. So at the top one, we have the initiator. We're just determining who initiated a process the most. We just pass that into a function, and then we send that up to our API layer, up to the user that requested it. And then down below, we have the same thing for duration. where we collect all that duration data and then determine the maximums and averages, and then send that up to the user that requested it. And then one last diagram. This is just representing what makes up a process. So a process has an action, it has an initiator type, and then an action comes from a producing application, and that producing application notifies others of the change through an event, and then we initiate that. We initiate that through a command, and then we receive a response message.
All right, so here's what our application looks from the front end. As you could see before, the bulk of the work was done on the back end and a lot of the data. So this is our sign-in page right here. We used Cognito, AWS, for the sign-in page. You can create an account, and you can also sign in. And it also gets verified with two-factor authentication through email. Move on.
So moving on to our front end, we built our front end with React. You can see here it's kind of just like a wrapper for our API. Just makes it really user-friendly to use. Obviously at the top we have two views. We have our duration and our initiator, where you can just enter your parameters and then receive the data in a table format. So yeah, this is the initiator, and then this one is duration.
So moving on to the value and highlights of our project here. So our product, brings value to the company with revenue-saving opportunities, with optimizing the system, finding those bottlenecks, and then developers can also more accurately gauge like how efficient any process is and just like the overall health of the system.
And then for our values and highlights, for our project results, we delivered an online observability tool for Mutual of Omaha developers. The tool can find inefficiencies and roadblocks within the Mutual of Omaha's distributed architecture. And then in terms of learning opportunities, it's been a really valuable experience with data modeling, AWS, OAuth, and Cognito. And sponsor communication requirements, elicitation skills is also a really big part of this. And we also utilized an iterative design process.